Hello everyone and welcome back to our Power Thinking Skills revision video. So today we are going to look at the 40 questions that make up test 30. Let's get started straight away. Question 2, we have 44 numbers, odd numbers that are multiplied together. Which of the following statements would be true? Let's test this hypothesis. 44 odd numbers. Let's try doing the first couple, okay? So we have, let's do 3 times 5. We get 15, okay? From here we can times it by 7. What do we get? Let's try. 5 7 is 35, 105. So far we can already see when we multiply two odd numbers together, we get an odd number. And when we multiply again by an odd number, we're going to get an odd number again. No matter how many times you do it, this would be 15, 0, 1, 3, 15. No matter how many times you do it, when you do odd times odd, the answer is always going to be odd. So 44 odd numbers, even though you're multiplying an even number of numbers, it is still going to produce an odd result because you're essentially multiplying odd numbers together. So the answer is B. Okay, and you can tell that by doing a short kind of trial of what would be happening in the first couple numbers in the series. Okay, number 4. A sheet of paper is folded half in 4 times from the longest side each time. If the dimensions were originally 100 by 100, what is the final area of the folding? For these folding or reflection or symmetry questions, I really highly recommend you guys draw. Okay, so let's first draw up a square. We have 100 by 100. We're going to fold it from the longest side. Well, there's no longer side here because they're the same, so it doesn't really matter which side. We're going to fold it like that. And what do we get? We'll get a rectangle that looks like that, 50 by 100, because we folded it in half. So we need to halve that dimension. Now we're going to fold it again from the longest side. So fold it down this way, and what do we get? We get another small rectangle, 50 by 50. Okay, so we folded it twice already. What do you notice is happening? We're actually dividing each side, okay, one time on the width, one time on the length, by half each time. So we're 100, 100, 50, 100, 50, 50. So next we're going to get 50 by 25. And then the final fold will get 25 by 25. Okay, do you see what we did there? So what would that be? The area finally would be 25 by 25. And if you multiply that, well, you know that would be 6. Sorry, let's write that again. 25 by 25, you'll get 625 square centimeters. And that's option D. Okay, 5. We want to find the flaw in reasoning. So let's read that short paragraph there. Statistics shows that ever since seatbelts have been mandatory, a high proportion of road users have been hospitalized with injuries from high-speed collisions, and Ross says that this means seatbelts makes driving more dangerous. What is wrong with Ross's reasoning? First of all, when you see questions like this, you have to be careful with this word proportion. It's not saying that it is a fixed number, okay? It's relative, so it's a comparison, like a percentage or ratio or a fraction of road users. Second of all, you need to find some holes in Ross's reasoning because they tell us that his reasoning is wrong. What could it possibly be? What you can do is have a look at the options, okay? So A, even though seatbelts become mandatory, this does not mean that more people wore seatbelts. Now, this is not directly the correct answer because it doesn't really relate to Ross's argument about it being more dangerous and the hospitalization. Okay, those are the key points there. And B, when seatbelts were not required, people involved in collisions were more likely to die rather than being hospitalized. You can clearly see how there is a link to the hospitalization here and the seatbelts and collisions, which was part of our main kind of point, and that actually makes B the correct answer. Okay, so what they're implying is that the seatbelts actually save these people's lives, and instead of them just dying straight away, they're able to be hospitalized, able to be kept alive until they got to hospital because of these seatbelts. So it's kind of contradicting Ross's argument directly. So that's why B is the best answer there. Okay, so for this one, ignore this. I accidentally added another line. Okay, so question 8. Harold is sitting a university entrance exam. The exam consists of 4 sections labeled A to D, varying in difficulty, and they tell us the number of questions in each part. So which one would help Harry complete the exam the quickest? So all you have to do for this one is really work out A to D, the amount of time that's going to take to complete the respective number of questions with the time provided. So let's try for A. For example, 3 minutes for part A, so per question, 3 times 15. I'm going to add that to 5 minutes for part B. You have 8 questions, so 8, let's do that. 5 times 8 plus 8 minutes for part C. So 5 questions in part C. So we're going to do 8 times 5 plus, and 15 minutes for part D. So 3 times 15, or 15 times 3. So we get 45 plus 40 plus 40 plus 45, which is 90 plus 80, which will give you 170 minutes for A. And you have to do that for the rest of them and then compare them. Obviously, this is quite tricky given the time constraints, but trust me, there are going to be questions like this, okay, or in a similar way where they kind of try and stall your time. Okay? And the purpose of these questions is to figure out who can complete such questions. They're easy calculations, but very easy to get wrong as well. Who can complete them in the most accurate and timely fashion. So when you get questions like this, don't get stuck. If you mess up a calculation, don't lose confidence. Guess an answer, circle it, and make sure to come back later, okay? Sometimes that panic in the moment does not help, so please remember that. For this specific questions, you can see from the solutions I figured out, and D comes out to be the shortest time or the quickest time with 167 minutes. So that's why D is the answer for this question. You can try figure it out on your own, like I did here. Out on these simple patterns as well. Some students tend to overthink and try too hard to use all these complex things. Eliminate all these simple, easy patterns first before you try those. Okay, 16. So, which of the statements, if true, most strengthens the above conclusion? What is the conclusion? Let's get our highlighter and highlight the conclusion. So we have deciduous trees, okay? They are quite a common sight in most of the northern hemisphere, but quite rare in Australia. Why? And one of the main reasons for this is related to Australia's unpredictable climate, and they go on to explain what is unpredictable about Australia's climate. So that's kind of the main point as to this paragraph, telling us about why deciduous trees don't grow that well or quite rare in Australia. So what would strengthen this conclusion? The answer is A, okay? Because this conclusion concludes, okay, or our highlighted bits, they show that deciduous trees are not common in Australia because of our unpredictable climate. This directly links to why they are common in the Northern Hemisphere. As I said, they are common in the Northern Hemisphere, and we can assume or we can infer that it's because they are predictable weather, unlike Australia. So A directly links to this conclusion very well with 2 main linking points, so that's why it is the best answer. Okay, 17. So for this question, what you had to do was find how many more small blocks are required to complete this pattern, okay, to make it a 4x4 full block. What you want to do is figure out how many blocks are in here already and minus that from a full 4x4x4 block. A 4x4x4 would be 16 times 4, which is 64 blocks. That is a full 4x4x4 cube. Okay, 4x4x4. and that's what we want at the end. Right now we have this kind of jumble of cubes. How many do we have now? I like to look at it in layers, okay? So that top layer, we only have 1 cube. And then that second layer here, we'll have 1, 2, 3, 4, 5. Similarly, this third layer here, this base, we would have 10. And this bottom, very bottom foundation layer, we would have 14. I just counted them up by marking them, okay? Now we add them all up, 1, 5, 10, 14. Try to make 10. 1, 5, 4 is 10, and we get 30. So we have 30 blocks right now. We want 64. So what do we do? 64 minus 30, and you get 34 as your answer, which is option A. Okay, 18. So Tom claims that more people are taking public transport. In the box it says total money generated. The total money generated by public transport has increased by 5%. And Tom assumes that because most people don't have a driver's license, there are more children taking the public transport. So what has Tom done wrong? So Tom has assumed that this total money generated is purely because more people are taking public transport, whereas that's not the only way the money can be increased, right? The total amount of money. A very possible reason or that increase is by a thing called inflation or price raise, okay? They might have increased the ticket prices, and that's why the total money generated or the total revenue has increased altogether. So this direct relationship between the number of people with the total money generated is not reliable or not inferable. So what is wrong about his assumption? The answer is D, that ticket prices have stayed the same. Okay, they might have, and his assumption might be correct, but we can't directly assume it just now without extra evidence. Okay, 19. So the distance between these two lines is told to be 15 centimeters. So how many circles is that actually? The radius of, sorry, the diameter of 1, 2, 3, 4, and we have 2 halves here which make up a whole circle, so 5. So this is 15 centimeters. What that means is that 5 of these diameters, sorry, I keep saying radius, is 15 centimeters. So one diameter would be 3 centimeters. So now all you have to do is count up how many circles there are. There's 9 along the length, so 9 times 3. And along here we have 3, so 3 times 3. So now we have some dimensions. We have 3 times 3 is 9, 9 times 3 is 27. And to find the area, you want to times them together. And when you do that, you should get to 3 square centimeters, which is option B. Don't do all that work and think it's D, okay? Be careful with your calculation. Okay, 28, a little bit more complex. So this is the kind of question I would say is another stalling question, okay? It requires a bit of calculations to be done. But if you can do it, then you get the mark. If you can't, please guess and move on, okay? 1, 2, 3 marks because of guessing will not harm your score, but multiple marks of you rushing, okay, or not checking, or not getting something that you should be able to get will definitely harm your score. So keep that in mind and do this test with a lot of common sense, okay, with a lot of test tactics. Okay, so this person is a baseball player, pitches at 90 kilometers per hour. So we are talking about seconds here. Let's convert that. 90 km per hour. So that in minutes, okay, so 90 k is 90,000 meters. And divide it by 60. And if you divide the number by 60, 60, we get 1500 meters. When you get to seconds, you divide by 60 again, same thing, and you get 25 meters per second. So he's going at 25 meters per second, okay? And it takes him 0.8 seconds to reach the ball to the opposing batsman. So how long is this distance? Well, if it took him 0.8 seconds, you have times 0.8. So this time you want to times 0.8, and you realized it was actually a 20-meter distance. Okay, 20-meter distance. Remember that. Now, he increases his speed by 60%. 60% is 3/5, right? So we're going to increase, well, actually, we can just do 1.6, okay? If you increase it by 60%, it's 0.6, but we have the one whole from before. So we're going to times the speed, which is 25 meters per second, okay, by 1.6, and you get that he can throw 40 meters per second. So I've done the calculations on this side to save some time. 40 meters per second now. Okay, he increased the speed. And that makes sense, right? More distance in the same time. So how much less time will it take to reach the opposing batsman? 40 meters per second. Okay, so how long is the distance again? It's 20-meter distance. Note the circled bit. Okay, so if it's a 20-meter distance, it takes them 40 meters. It's a 40 meter per second. So for 20 meters, it's half, isn't it? Okay, we'll times 0.5. So we're going to times 0.5 here. You actually get half of a second. The whole 40 meters takes 1 second. So 20 meters will take 0.5 of a second. So now we want to figure out how much less time, so minusing. It originally took him 0.8 seconds, now it takes him 0.5 seconds. So you're going to do 0.8 minus 0.5, and you get 0.3 seconds difference. Okay, or option D. Hopefully that makes sense. Okay, I know that's a long question. Like I prefaced, this is not expected of you, okay? It's a quite difficult question, but if you get it right, kudos to you. If you didn't, that's okay. Hopefully you got other questions correct. 32. Which strengthens the Brazilian government's new policy? What is the policy? The Brazilian government here, as a result, has decided, let's highlight, probably better, to introduce a new policy, increasing the legal driving age from 18 years old to 21 years old. We want something that strengthens this, okay? Strengthen, makes it stronger, supports it. The answer here is D, okay? 60% of the road accidents are as a result of drivers aged between 18 and 21 years of age. This is really good because it directly links with this age policy, okay? The whole policy revolves around age. If a lot of drivers age between the limits that have been mentioned in the question, okay, that directly supports why Brazilian government might want to up the age limit so that everyone under that age won't be able to drive. Hence, road accidents would become more rare, okay, we'll have less. So that links to this, okay, the road accidents, which is the whole purpose of this policy. So D is the answer here. Thank you for bearing with me in such a long video, and till next time, try to keep that takeaway in mind and apply it in your next exam. Thank you very much, and see you soon.